So, quick show of hands, who here has heard about Flyte before? Oh, nice. Of, the few of you, is anyone running Flyte in production? Oh, amazing. Talk. This is pretty awesome. I'm just asking this because this talk we'll have an introduction to what even Flyte is, and then we'll get, our hands dirty. If you want to follow along, that's what the story is for. So let's go, talk about Flyte. First, a little bit about myself. I am the engineering manager for the OSS team at Union AI. We're going to talk a little bit about, what Union is. But I've been doing software and straddling, the border between like infra and product for a long time, and I just love the idea of open source. The fact that, we can be so successful, so helpful to people all around the globe, really. It's such an amazing idea. So, but first, let's change users. Union, what is Union? It's a company that was founded to help people leverage Flyte in their, their own problems. We want to ensure that people can use Flyte without having to worry too much about the infrastructure. If you're curious, go to union.ai. Enough about Union. Let's talk about Flyte first. What is Flyte? Why did we even build Flyte in the first place? So let's talk about the usual, life of the machine learning engineer. You have some data set that you want to derive some insights from. You write your usual loop where, hey, I have this idea, I have this algorithm that I want to try out. You do it in your laptop. You scale it out to production. Hey, now, I want to do distributed training using, PyTorch or Ray or whatever. Finally get to production, you start to monitor, and you go back, right? Everyone who's been doing data science or machine learning has gone through these loops for, a long time. At Flyte, we understood that, hey, there is a certain way of looking at this problem that really, it means three things. Machine learning pipelines under the covers, they're really data pipelines. Data is essential, The software is, it's a problem, but like we've been developing strategies and techniques to deal with software for the longest time, but data is complex and stateful. Things change, data, your models deteriorate, you need to have a way to capture that discrepancy. And here where Flyte and some other tools in that space, they come in. That's why we built Flyte, Just look around. The ecosystem across all the different steps in the machine learning and data space is just like gigantic. There is no one text box solution. If you think about, how to really look at any other process. How do you load data to how do you even do training? How do you serve? How do you run experiments? How do you monitor them? So Flyte looks at this and proposes a solution. The second challenge really is you are part of a team, you're developing your models, your data sets, but if you don't have a structured way to go and iterate through this loop, you're gonna have a hard time. So examples of problems. Hey, you might have uncached data or unvalidated data, which is even worse. Sometimes, who here hasn't been on a team that you have this data scientist, this person's brilliant, but their code only works on their machine or in a specific, setting. You want reproducibility. You want a way to take that model and so that it can run anywhere, right? When we get to production, you have model, you're monitoring, you're evaluating the results, but how do you track what's happening? What if there's some data drift happening? You need a way to add structure to the iteration process when it comes to machine learning models and data. But that's, what we talked about in challenge 2. It revolves around the single team structure. You have a team, multiple people, but like this problem only gets worse when you have different teams working in different parts of the pipeline. So Flyte also recognizes that you need to have a way to establish contracts, establish a way for multiple teams in a big org to communicate and work together. The moment you start thinking about machine learning models that are big, you, as the data scientist or machine learning engineer, you need to start thinking about infra. It's just how we are or where we are in the problem right now. There is no way to just say, hey, yeah, I have this beautiful idea. Let me run it on 1,000 machines. Like it does not work like this. There's no solution or textbook solution. Again, go back to that idea of having a way of doing this. Idea of an abstraction is to crack a way to really break if you need more resources to train and run your workloads. Finally, there's a lot of solutions out there that let you express computation, but in a static manner. Like there's no way to run stuff like run a grid search where you want to do a hyperparameter optimization and you have like different parameters that you want to pass through a specific graph. So Flyte also recognizes this problem, and we propose a solution. Orchestration. Orchestration really is the answer to these 5 challenges. The orchestrators out there, and this includes Flyte, they let you express computation in an ergonomic way, where you go from, you have this raw data, you turn it into your desired state, and here by desired state I really mean any part of the machine learning line, from models to monitoring to experiment tracking. For each one of these 5 challenges, this is what I really would love to see in an orchestrator. I want to be able to use whatever tool is appropriate for the problem, In the data science and machine learning space, like Python really is king, but we're starting to see, people using different languages, different frameworks. Like, what if we had a way of accommodating all of that in a single system, right? I want out-of-the-box support for, all things versioning, lineage, caching, immutability. Like, this will help me build these bulletproof pipelines. What if I also really need to acknowledge that a model doesn't exist in a vacuum. You have multiple teams in large orgs working with machine learning pipelines. So I need to recognize this fact and design around it. I really want a way of expressing my requirements in a declarative way so that I don't have to worry about, hey, am I running with 5 gigs of memory with this version of PyTorch? I want a more abstract level that lets me express what are my requirements in a more declarative manner. And finally, static DAGs are great, but I need a notion of dynamism when it comes, to more complex algorithms. So let's take a look talk about how Flyte tackles some of these challenges. This graph has a lot, so we read it from left to right. On the top left, you see I'm mentioning tasks and workflows. We're going to talk a little bit about what they mean in a second, but think about this as your pipeline. Here on the bottom left, there's a small DAG, 5 nodes, doesn't do much, but Flyte gives you a simple way to go from having your code expressed, here using Python all the way through a Kubernetes cluster with the dependencies mapped and parallelism controlled by you, and what instances you want to run this on. So we go from having code on someone's laptop. Yeah, you have your DAG expressed using testing workflows, all the way through pods running in a Kubernetes cluster. And Flyte gives you this layer in the middle that gives you versioning and in a way to track what are the actual tasks that are running. We do this by a process that we call packaging and registration. So what I mean by this is you have this two-step process where you containerize your code. So the little whale at the bottom there, it's a bunch of Docker images that you create based on your code, and there's some Flyte-specific configuration that teaches, quote unquote, how your DAG should be run on a real Kubernetes cluster. When you go through this two-step process, we produce the graph in the middle, the thing in purple here, which is essentially the Flyte's notion of how your DAG looks like, and eventually this gets fed into a Kubernetes cluster that schedules your computation. Let's add more meat to these bones. So let's talk about tasks. Tasks are the smallest unit of computation in Flyte. So they are containerized, they are versioned, and they are strongly typed. So here we're talking about something very abstract. Like a task really is just a bunch of Python code. But in Flyte, we give you a way to express types in the SDK itself. This will become important, very, very soon. But again, this idea that task is the smallest computation unit, it is containerized. It gives you versioning for anything that runs, and it's also strongly typed. You take tasks and you compose them in workflows. So again, this idea of being strongly typed, So workflow is a composition of tasks, but workflows themselves, they are also strongly typed. They're also versioned. They take care of flowing the data between the tasks. You don't have to worry about expressing, hey, this task's output is piped into this other task's input, like Flyte figures out for you. We also have launch plans. It's just a way for you to customize and schedule the invocation of workflows. That's super important. Finally, dynamic workflows. It's a way for you to compose a workflow at runtime. Remember that idea that we talked about? Static DAGs are amazing, but sometimes you need a notion of dynamism. Dynamic workflows give you that. Projects and domains are also a first-class citizen in the Flyte programming model that gives you that clear separation between teams. You have projects and you have domains, and you can use this to help different teams work on different pipelines, and you basically stratify this by using the combination of projects and domains. That's all nice and fine, but you probably have seen similar ideas in a lot of other orchestrators out there. What's unique about Flyte? First of all, here I'm describing a workflow composed of 2 tasks, and if you read can you see the red arrow there? So here I'm describing a workflow. This is the white box there. Takes an input, an integer. It pipes that integer into a task that I'm calling here, create data set. That task has an input, a single integer, it outputs a data frame. That data gets fed into a second task that I'm calling here train model, which takes a list of dictionary as an input. See that the types, they don't match? Flyte will give you this piece of feedback at the moment of registration. It won't even let you schedule this kind of computation on a Kubernetes cluster, which, that idea of being ergonomic, really helping the developers get this feedback as soon as possible. It's a feature that Flyte gives you. Also, the framework is language independent. Our main SDK is in Python, but nothing prevents you from writing your computation, your tasks and workflows in other languages. Spotify maintains the Java SDK, if that strikes your fancy, but we also have ways for running what we call raw containers, which really, as the name suggests, it's up to you to describe how to handle inputs and outputs, which gives you the power really to use literally any language. Rust, here, feel free. Here, I'm just describing a workflow that, it uses a bunch of languages, frameworks, like, hey, it takes the first task at the top there, handles, Spark data frames, hands them to, a task running PyTorch. Also R finally feeds that into a task that is running in the AWS SageMaker. It just hints at this idea that you can call external services in your Flyte workflows. Another powerful idea that I think it's a feature that is well integrated into Flyte. Like you have this really simple way of declaratively expressing your dependencies. Here I'm again an example of a workflow composed of 3 tasks, and in each one of these tasks we're running a different computing platform. So first task here, it runs on a Spark cluster, and on the right hand side I'm emphasizing that Flyte really is taking care of the spinning up and tearing down of each of the computing platforms. So in this case, your workflow spins up a Spark cluster, runs your task, tears it down, pipes the data to the next task. PyTorch, or like doing some training using PyTorch. Also, that thing runs on a specific set of nodes that contains your GPU pool, and finally you hand that back to a task that runs on an array cluster. You're doing something fancy with some machine learning model. Great. Flyte is agnostic. It really lets you express this kind of computation declaratively, and I'll put more meat into those bones, like what I mean by this, when we get to the tutorial portion of this task. Finally, and this is, I think it's one of the biggest features that Flyte gives you for free, is this idea that you don't have to worry about how the data is shifted, where it is moved, and when you're expressing your computation. Again, simple example here, we have a flow that's composed of 2 tasks. One runs on a Spark cluster, another one runs on a PyTorch, bunch of GPUs. Flyte does the heavy lifting of converting from, let's be super specific here, like PySpark data frames into like PyTorch, and you don't have to worry about it. You don't have to write that code, that serialization code. Some people, they are using Flyte, Spotify does their accounting for forecasting. For those who don't know, it's doing early detection of cancer using ML. It's great using Flyte. Black Shark is doing 3D mapping of the world, processing a crazy amount of data. They also use Flyte. Kojak doing price optimization, rider matching in Asia. Great. Now let's get our hands dirty. We're gonna work through 11 examples of a very, very simple machine learning pipeline that uses the Palmer Penguins dataset. We have these 3 different species of penguins, and we want to create a model that predicts what is the species given like the bill length and bill depth. Here's how the data looks like. I just didn't want to use the iris dataset. I want to do something a little bit more interesting. Oops. But it's showtime. If you want to follow along, please hit this URL, tinyurl.com/PyData-Seattle-2023-tutorial. I'll switch. This will land you on this GitHub repo that contains a bunch of files. If you scroll to the bottom, go to setup here. Is the zoom okay? Okay, cool. I'll bump it just once. So you have 2 options if you want to follow along. Union has this idea of a hosted sandbox, which is essentially a small Flyte cluster that allow you to play with Flyte. It won't let you run anything super big, but at least for the examples that I have today, that's plenty enough. You can go to sandbox.union.ai. You have to sign up with your GitHub or Google account. I don't know if we added Microsoft. Oh, I'm already signed in, but sorry. If you want to follow along, hit there. You probably see this screen that let you start a sandbox. Once you hit that, you can click on Code Editor. That will bring you to this sort of UI. This is VS Code running on the cloud. You don't have to, really install anything. Again, you just want to get a taste of what Flyte is. The other option, if you want to run this in your local box, or you want to run, more complex workflows, in the same instructions, I have a local section here that lets you, install this locally. You have a self-contained Flyte cluster. It won't bring your machine down or anything. It just runs Kubernetes inside of a Docker container. And this is what I'm gonna do to demo and go through the rest of the tutorial. So here, I put the theme as, set the theme as white, just because I think it's easier on the eyes. It's probably better. Great, cool. So if you want to follow along, as I said, we have 11 examples. Again, I don't know if the zoom is okay. I'll just increase this. I think it's fine. 11 examples that we'll go through, the 5 challenges that we talked about. How do we do scalability with Flyte? How do you handle data quality? Reproducibility. Flyte has this great feature that lets you recover from system problems, so that you're in the middle of a 5-day training job and something goes wrong in your Kubernetes cluster. Like Flyte gives you a lot of flexibility in how to recover from that. And we'll go through some auditability exercises. So feel free to follow along. Instructions will just install the Flyte sandbox that I was just mentioning. But first, let's go and take a look at some code for real. Is this, so I'll just increase this a little bit. Great. So, as I said, we're going to use the Palmer Penguins data set. It's not a complicated, logistic regression that we're going to write here. It simple Python function takes a few parameters, hyperparams, how big is the test size, so that how you split the data, and some random state for why not. We do get the data. This is just loading the Palmer Penguins data set. We split it, train a model, evaluate, compare that with test, and return it. So really, like nothing out of the ordinary here. We've written this kind of code all the time if you played with machine learning or you are a practitioner in the field. And if you look at this, like this is just Python, right? You're just like calling a bunch of Python functions. What's special about Flyte? Let's run this on the Flyte. These instructions don't really matter. Let's take a look at this code first. So you have what I'm calling here remote, which is just a way for you to programmatically interact with a Flyte cluster. This will essentially get a connection to the Flyte cluster running in my local box. And we are calling execute workflow, passing some function, which is the function that we're just talking about now. And specifying some inputs. We'll see what the console means in a bit. So let's kick this one off and go over, take a look what Flyte looks like. So this is small, it's probably too small. Great. So at this point, the function that we called in our workflow, get data here, which for all intents and purposes it just looks like a function call, is running on a real Kubernetes cluster. And notice how if you go to the graph view, Flyte produces this visualization of what your workflow looks like. So you didn't have to do anything to get a sense of how your workflows look like. You can click on any of these boxes. You get access to the execution of each task with its inputs and outputs and some metadata or meta information for like how the task runs, which is not super important now. But the idea is, hey, you ran a workflow that we're calling example 0 intro.training workflow at version 0. Like this is user generated. Like we decided that this execution of this, the training workflow example has version 0, You can come here, the workflow finished. You can, you have access to all the data that flew in and out of each one of these tasks. So let's do a small comparison here real quick. So I think it's Alt. Yeah, so take a look at get data. Go to the definition. Take a look at the get data. Get data returns a data frame. And then we get that data frame, pass it to split data, which in its turn doesn't do anything super special, but the type hints here for the return type of the function tell us something super important. We have like split data gets that data frame that you passed as a parameter and splits it using the other two parameters. But like if you go back to Flyte and you take a look at how split data looks, like you get the inputs So like the data, the random state, test size, but take a look at the outputs. Now, you can, by just inspecting the results of the split data task, you can go to your blob storage. In here, it looks like an S3 address or URN, but really this is running locally. This is using Minion under the covers. But the idea is you have full control over every step of your workflow. You could go back to this task and just like rerun it if this is what you want to inspect. And this applies to all the other steps of your workflow. Like, I think this example is not too complicated. But look at the structure of your workflow. It just looks like Python, you know? You didn't do anything special. You're just like, hey, here are a bunch of functions. I use these decorators at workflow and at task to define, what the tasks and workflows. And for all intents and purposes, if you look at this code, like it smells like Python, you know? Which means what would happen if I ran this locally, right? So let's, I set a breakpoint here so that we can inspect some of the intermediate states of these function calls when you run your workflow locally. So let's see what happens. Great. And I don't think I need this anymore. So I'm for those who don't use VS Code, we're stopping at this line here, line 81. I just want to show what are the types of these objects that we used to describe our workflow. Check the types, like all of them are of type promise. This is an internal promise object that Flyte uses to give you this contract of the inputs and outputs, like the types match, or you have a way to delay the computation. So again, if we're running this locally, this is running my laptop, this is not running the Flyte cluster, which gives you this ability to experiment locally and very easily translate your computation to run into a real Flyte cluster. So just so that I'm not lying, if we run this, wait, get the result here. It's a logistic regression model. Again, not super important. The main idea here is that you have the freedom to run Flyte workflows locally and very easily use a Flyte cluster to run your workflows in a real Flyte deployment. And the way we're doing this is by using, here, we're using the programmatic interface. So we're controlling this execution or kicking off executions using remote. Flyte gives you a lot more options, like you could come back to what we call the Flyte console, the Flyte UI, and you can launch workflows from the UI. We also have some CLI that you can use if kicking off things manually is not your thing. But let's try to make this example more interesting. We talked about the notion of dynamism. This need that sometimes you just need to have a better way of expressing dynamic computation. So I'm going to extend this, the simple algorithm that we're using for this example, and now we're going to add some grid search to find what are the best hyperparams for this simple logistic regression model. So let's go back to the how we augment this workflow. Again, we have a function I'm calling it tuning workflow here. Following the 0, example, we get some data, split it. The change here is now we have this function called toModel that does something more interesting. If you see, now we're using a different decorator that we call dynamic. Dynamic essentially lets you express dynamic computation more easily. So being super specific here, if you take a look at these 4 lines that I'm highlighting, we are essentially running, we have multiple executions of the training model running in parallel. And instead of, having a static definition for those calls, notice how we build this list of executions on the fly based on the hyperparam grid argument that you pass when we call toModel. How does this look in practice? Let's go back and take a look. So go to the UI, take a look at the graph model. It looks very similar to the graph view that we saw for the simpler example that we ran. So I'm just opening the two. Instead of having just a single call to train model, now we have this function that will run the grid, calling train model multiple times based on the hyperparam grid argument that we passed, which, if we take a look at the example again, we are passing this list of 3 elements. So just like running a really small grid search, only 3 combinations of parameters. But again, the main idea is that you have this notion of dynamic embedded in the TSDK. You don't have to worry about like expressing hyperparam grids with other constructs or reaching out to other computing platforms to do grid search. You have a question?
So perhaps I'm jumping ahead a little bit, but I'm just wondering, how does Flyte know to run those tasks in parallel? And how is that different than like there's the map task function? Like how is it like just a list comprehension that would normally be single threaded? How does Flyte know?
Yeah, that's a great question. So let's go to the actual code of dynamic. You're essentially talking about the 4 lines here, right? Yeah, so under the covers, what is happening is that Flyte is taking this entire function and building a workflow on the fly. So it's not running the list computation and running the actual computation on a task. The dynamic here means that you're building this workflow on the fly. And then Flyte just takes that DAG that you build dynamically and uses a similar infrastructure to schedule all those executions in parallel. Does this make sense? It's slightly different than map tasks, but we're going to get there. I think it's the next example. Yes.
Yeah.
We can talk more about it later, yeah, but there is.
It's very strange, right? Because like it's just anyway. Thank you.
No. I think it's a fair question. There's a lot happening right here. Like when you are programming using the Flyte programming model, you need to keep in mind like at which level of abstraction you are. Like when you are inside of a task, that is just some Python code running in a container somewhere. But workflows and dynamic workflows, they are these meta descriptions of how computation look. So this list comprehension here essentially tells Flyte that you have these small computation units that need to be scheduled at some point.
I guess what I'm wondering is like, so what if trained model had a side effect that made it not thread safe?
So each call to train model will run in a separate container. Like the actual computation will run separately. You're not really executing train model when you are in a dynamic context.
So does Flyte know to run this in parallel because the return type was a tuple and it's a dynamic decorator? Is that like a combination that tells you?
It's a good question. No, it's the fact that you're inside of a context of a dynamic. Like you are free to choose whatever signature for your dynamic workflow. It's just that you're building the dynamic workflow on the fly. That's the idea of dynamic.
So, but a trained model put that to be annotated with that task.
Exactly. Yes. If you don't do this, then
So it basically knows that it's special because that function has been annotated, and so then that's why it knows not to execute it.
So I think if we go to the definition of train model, like train model is just another task. Like as you're saying, like we're instructing Flyte that train model is this computation unit. It will run in a separate environment. It will run in its own separate container. It's just that we're building the DAG dynamically. That's the idea. But it's just another DAG at the end of the day, where each task becomes its own separate, isolated environment running in a separate container. That's a good question. Let's go back to examples here. Yeah, you stole the thunder a little bit, but let's talk about map tasks and what they mean. Sometimes dynamics are too general for the kind of computation that you want to express. In the case of embarrassingly parallel computation, Flyte provides you this construct that we call a map task. And when you look into the code, this is how it looks like. So if you go to tune model, yeah, so again, similar to now how we did in, let's just compare these two side by side. You have tune model here where you have like this list comprehension where you return models, but using a map task, you can leverage Python to express your computation in a slightly more ergonomic way. So here you have a map task that takes, similar to how Python's map function work. You take a function and you take a list of iterables, and the Python runtime takes care of mapping that function over the input. In Flyte, we have a similar construct called a map task, which also takes a function. The concurrency is just so you can control like how fast you want to run. It's not terribly important, and it takes the iterable or iterables that you're gonna map over. So let's go over what this partial here, this partial really means. Have a function called train model. You take a look at the parameters for train model. You take a dictionary and a data frame, and it just instantiates logistic regression model. Oops. Go back to train model here. again, you have a map task that takes a function, and here we're using some Python magic to fix one of the inputs to the train model function. We are saying, hey, Python, create me this partial function. For those who haven't used, partial applications in Python, functools, the built-in, it gives you this idea of basically freezing arguments to a function application. So in the case here, or in this case, we have a partial application of the train model function or task where we force data to be the train data. And we map this over the list of hyperparams that we passed in. Compare this to how the list comprehension looks like. In some cases, it's simpler, or people feel much simpler to use map tasks just because the intent is so much clearer when you have these inversely parallel computations, right? Where you have a function and you have an iterable or iterables that you just want to map over. Yeah, sorry, we haven't run this. So let's take a look at how this graph looks like and compare that to the other example. Again, the difference here is in the tune model. You have when we get the tune model, now you have this smaller, I'll call it smaller DAG that just runs a map task. And if you go to the nodes view and expand what tune model is doing, give it another second or so. Yeah, I want to show that if you click on the map task description, you see here on the right-hand side that you have 3 computation units that are running or need to run, and Flyte is doing the heavy lifting of scheduling them in parallel, obeying or taking into consideration the concurrency that you chose for your map task execution. So this would, in this particular example, this is not super interesting because we only have 4 hyperparam elements in that list. So this doesn't really apply, but let's say you had, you're trying to run a grid search and now you have, 300,000, or maybe not that high, but 3,000 combinations of hyperparams. Instead of, overflowing your Kubernetes cluster, you can control how many instances of that computation will be run at any point in time, at most, if that makes sense. Any questions? All right, let's keep going. Flyte also has this idea of plugins, and here I'm using the word plugin very loosely because this means very different things depending on what we're talking about. So let's go over a small example. So again, we're building on the Palmer penguins example. We have a training. Okay, so we have a training workflow that is getting some data, which is what we already saw, but just so. Now, instead of downloading the file that's provided by the Palmer Penguins example, we're using SQLite to actually run a query hitting this data set example that has the Palmer penguins data set. Notice how you didn't have to change anything in how you define the workflow. So just to go back to this, let's go back to the actual workflow. So this is the workflow that we're talking about here. It runs some pre-processing and gets the data using this function that we're just describing here, which runs a SQLite query that returns an object of type penguins data set. It runs this query, just gets all the data from the penguins table. Flyte has a way for you to add, to describe a schema in a strongly typed way. So go back to how this SQLite task looks like. Calling it get penguins data. Here's what the query that's going to run. The important part here really is the output schema type. Take a look at this. I'm telling Flyte that you're going to run this SQLite query, and you're going to return the data using this schema. Flyte's going to use this schema here with these columns of specific types that you chose to do the type matching. So when we call get data, let's go back to the workflow. We call get data, we're calling get data, returning that penguin data set, passing it to pre-processed data now. Let's go take a look at how pre-processed data looks like. Take a look at the input of pre-processed data. It takes a penguins data set, which is a structured data set with the columns of specific types that you chose, which essentially means if you want to use penguins data set in another workflow and the types don't match, Flyte will let you know. What pre-processed data does is not terribly interesting. Let's go back to the workflow. We finally call train model, which is doing, it's a dynamic task. It's a task that we're going to talk about the resources later, so don't get too fixated on this, but there is a kind of plugin that enables you to support, external types out of the box. So, for example, PyTorch the NN sequential from PyTorch. It's a good example. But we have other kinds of plugins, like for whatever reason you're using polars or moding or Pandera or Onyx. These are all FlyteKit plugins that you can use to describe your computation more ergonomically. Again, what this training model function is doing terribly exciting. Feel free to run this more locally. Just in the interest of time, I'll speed up a little bit, but I just wanted to show that you can have these integrations with external frames in very simple way. They integrate well with the type system. Anything more interesting about this? Oh yeah, we briefly touched on that idea when we were talking about these slides here, like this. This workflow, this white box or white rectangle that you're seeing there, what I'm representing there is a workflow that takes different input types and output types, and it takes care of spinning up and down the necessary infrastructure to run that. But the interesting bit that I want to emphasize is that in order for you to, let's say, return a Spark data frame from a task and piping that into like a PyTorch, like a task that uses like PyTorch, and you're gonna like run things on GPUs. Like, you don't have to write the glue code that transforms a PySpark data frame into a Pandas data frame. Like Flyte, under the covers, everything is Parquet. Flyte is giving you that for free. So go back to here. What I mean is, let's say you had, in your workflow, you're using this task here. Let's take a look at this. This is a task that takes a PySpark data frame as an input, and it returns a PySpark data frame as an output. If you had some data that you're loading from some other data source that was returning like a Pandas data frame, and you're piping that into this task, you don't have to do some casting or convert the actual representation. You just pipe that right in. Meaning, let's say you had, let's write this real quick here. If you had something like this, you had like a workflow, WF, and you get some data. Let's say this type here is PD.data frame. If you were to call pre-process PySpark doing this, Flyte, it would work. The types would match. Like, you can obviously check the schema, but notice what's happening here. Like in get data, we would be returning a data frame, okay? And pre-process data Spark takes as an input a PySpark data frame. These are not the same types, but under the covers, Flyte recognizes that these two types can match, and Flyte does the conversion for you. So you don't have to write that glue code. It's just what I mean. Which is very powerful. And we have these conversions being done for different types of data frame representations. And they all, are, well, you have a question. Great, cool, what's up?
Yes, if you have a team of multiple people working on kind of like an ML orchestration system, and I guess in the Flyte kind of vernacular, that would be like, a lot of workflows kind of coming together. If multiple people are like editing a workflow and stuff like that, like how can you, is there a way in Flyte to kind of see what changes are made over time, and kind of like a versioning sort of like mechanism?
That's a great question. When you register a workflow, one of the parameters that you take is a version. So by construction, any workflow or any task has a version. Okay. So yeah, you'd probably use this outside of Flyte to do the tracking. But the fact that you just cannot write or define a Flyte entity that doesn't have a version associated with it.
Then at least people can tell when it's changed.
Yeah. And also, keep in mind that you can have multiple projects and domains. So to also help in this stratification of who does what when, Like you have a team, what I mean by this is you have a team that's just iterating, over a model. They use project A in like a staging environment. At some point, that team decides to go to production. They use now the combination of project A and it's called production domain. That is the contract between that specific team and other teams that are using that model,
Yeah, that makes sense.
So, cool. Any other questions? Cool, let's keep going then. Have a fair bit. All right. Now we shift gears a little. Instead of talking about plugins and wait, why is this still running? Doesn't make sense. Give me a skip back. This is already finished, no? Yeah. Visual Studio crapped out on me, I think. Should have finished. Yeah. All right. Sorry. Jupyter books are great sometimes. Let's talk a little bit more about the type system. I already alluded to this. You know, we take care of in Flyte to do this conversion of different representations for data frames, but it doesn't stop there. Flyte has this idea of fast registration. Remember when we talked about this process here of going code on someone's machine to actually running, you have to go through registration, which essentially means a two-step process. You need to provide a Docker image for that version of your workflow, and you need to teach Flyte, quote unquote, about the actual structure of your workflow. It's this first step that sometimes is too cumbersome, and which is tackled by what we call in Flyte fast registration. You don't necessarily need to build Docker images all the time. You can use this cheaper process that we call fast register that allows you to iterate faster. You still get the benefits of versioning all your workflows, but you're not building images all the time. So we're gonna leverage this for this example now. Let's go to type system, example 4. Again, what's the name of the? Yeah, so example is not terribly important. Let's take a look at get data, definition of get data. It's just loading the Palmer Penguin data set and returning a data frame with some format. This type here is Pandas data frame. Let's run a quick example here, and instead of having this return a Pandas data frame, it's just for giggles, change the type for get data from Pandas data frame to dict, and see what happens when we try to register this using Flyte. So, wait, how do I? Doesn't this work? Yeah, right. Here I'm in the terminal. I'm just running PyFlyte register that specific pair, project, and domain, passing the image that we built in a previous step. We're not going to build another image now. We're just trying to register this new version of the workflow and see what happens. We get an error, a scary error. Oh God, this is terrible. Great. Just to translate what's happening here, we are trying to register a new version of this task, the get splits task. And this thing failed by saying that while we were trying to compile your workflow, the types don't match. You have a get splits that for this specific version that we're registering now, and it's auto-generated, for this particular example. It's on you to choose the version, but if you don't choose a version, we just hash your code, produce a hash, and use that as the version. But this is saying, hey, there's a mismatch in types. We expect that you'd be giving us a structured data set type but you're giving us a struct, which is in Flyte, the Flyte type system is how we represent dictionaries. These types of match, you are not allowed to even register this change, which, think of having this kind of change going through a CI process where right there you get feedback that, hey, the change that you're trying to make doesn't really work here.
So I'm just wondering, I can see this, potentially blocking you when you're trying to do something with Python's type system because it's.
Yeah, it's very strict, huh?
It's very strict, which I think is a good thing in some respects, but also, sometimes my linker gives me false positives. I was just wondering, is there a way to ignore that? And then also, is it possible to use user-defined types with Flyte, or does it have to be like Flyte?
Good two questions.
Okay.
So first one, is there a way to disable the strict type verification that you get when you try to register a workflow? The answer is no. You need to, if you want to run or register, any piece of computation using Flyte, you are forced to abide by the type system. We understand that it is strict, and sometimes it's not necessarily the way people work with Python, but we're playing a longer game here. We want to ensure correctness at any point. And the second question, I forgot. What was the second question again?
So I'm wondering if you can use user-defined.
Oh yeah, user-defined types, of course.
For example, you could use a protocol class to define, this has this is a dictionary, but really is actually something else. It might be a typed dictionary, or it might be something else that defines get item.
Yep.
And so you can treat it like a dictionary when you call that method, but not generally it's not the same type. So if you could handle that, or can it handle duck typing like that?
Great question, and the TLDR is yes. You are able to define your own transformation. So again, what Flyte does under the covers is that it gets the Python native types or whatever language you're programming in, and compiles that down to the Flyte type system, and does that back and forth, so that you never really have to worry about the Flyte type system. If you're just using it as a user, right? If you're defining new user types, there's a contract that you have to abide by to define this kind of transformation that you're mentioning, where I have my own type. I want to represent that using Flyte's type system. There is a escape hatch, and it's not terribly complicated. Does this answer your question? Yeah. So you can use whatever user-defined type that you want. We ship with a lot of extensions. I already mentioned the moding data frame, Onyx. There's a lot, and extending that is pretty simple. Cool. How am I doing on time? Okay. In the interest of time, I'm going to skip these two next examples because I really want to talk about caching. So let's go caching. So sometimes the kinds of workloads that you run on Flyte they're very heavy. They run for an extended period of time. So in recognition of this kind of computation, Flyte gives you the ability to essentially cache the results of any intermediate task, really. So the way you express this using Flyte SDK is in the task decorator, Let's go to, let's get data. Yeah, split data. So just to refresh real quick, here's the workflow. This time we're changing the type of the model, but it doesn't really matter. We get some data, we split it to the model. Take a look at the split data. Wait, why is this? Great, split data. I don't understand what this means. I don't care. Go to definition. Oh my God. I want this. Yes. Highlighting here how you can instruct Flyte to cache the results of any computation. So you just do set the cache field true and you give it a version. Remember, again, this ideal version is pervasive in Flyte. Like you not only version workflows and tasks, you can also version the data that you cache. It's all user defined. You get picked. These, the results of running tasks can be reused across different workflows, even different, project and domains. But how does this look like when you run in Flyte, like in the Flyte UI? Like how I can help to see how what is being cached, what are the versions, does caching even work? This should run. Okay, so we're interested in what's going to happen when split data runs. Yeah, great. See this little icon here? This is essentially telling you that the result of running this specific task was cached, which means that if we run this workflow again, we're not going to pay the cost of executing this in a separate container. We're going to get the result from the cache. If you go back to, so in tune model, which is a dynamic in this example, like we're calling split data again, and the result of train model is also being cached. So just to confirm this, go back to caching. Train model here is being cached with version 1. This should run in another. Wait, why is it being so slow? Great, so we're almost there. Just want to rerun this and see how much faster we can make this workflow now that we're caching a lot of the intermediate steps. Tune model, the last one, we're getting the best model. I know I didn't touch on this, but you can inspect the actual logs for any of the containers that are running in your cluster directly from here. You can configure this to ingest your logs to Stackdriver or any other like these platforms that let you store logs. So let's go relaunch this to show that the task executions or the cached executions, they don't run, they don't produce new containers. Like see how this was essentially instant. Same to tune models whenever that runs. Yeah, so, oh man, this is taking its sweet time. Demagogues are not happy. Oh, great. So yeah, so we cached the result of all calls to the train model. You can see by this little icon here that everything is cached. We didn't really wait any time basically to get access to the results of these previous computations. And finally, I want to leave some time for questions. So when I skip these two demos, talk about what in Flyte we call Flyte tags, which is essentially this idea that you can produce descriptions of your tasks in a very ad hoc way. And what I mean by this is, as long as you describe and as you can generate some HTML that describes the result of that task, you are free to use Flyte tags. So let's take a look at this example real quick. So again, we're not doing anything super special here. Have a workflow that does it has two tasks, one called get data, another one called get data annotated. Let's take a look at get data first. In get data, we are adding this little bit of code here that essentially creates a new DAG while get data is being executed. We're calling it data profile, and it's using this frame profiling renderer, which will summarize the data frame that we're loading in each one of the cases. Like in this case, get data adds the DAG, calling forcibly. So you're instantiating an object of type DAG, calling it data prof data. And in the case of the other task, get data annotated, we get a DAG again, but this time by simply annotating the output of the task with the frame profiling renderer and annotation. So how does this translate to a real artifact? So let's run this workflow. This is slower than I would like, but give it another second. Oh, great. Cool. So just so I'm not lying, like this is a workflow, works only two tasks, they run in parallel. But if you now inspect this little button here that says Flyte tag, now we have a thing that we're calling data profile. Remember, this is what this means. Go back to the code. In the case of get data, we produce the DAG that we're calling data profile, and it's using this DAG, frame profiling renderer. And this is how it looks like. Essentially, this calls, if we have the code for this here. Yeah, so this thing is just calling, creating a profile report using data profiling, data frame summarization package. And you get all this for free. This is HTML that was produced as part of executing your task. If you're wondering, you get DAGs for free for all inputs and outputs. In the case of data frames, we just run get n, which by default just shows the top 5 and the bottom 5 rows of a data frame across and using all columns. But you're free to define any visualization for your data, even for your user-defined objects. Here I'm just showing you one case where, again, I'm creating this object called DAG, which uses this renderer, but this renderer can be user code. It can be, you have your internal representations for data. You just define it yourself, which is what the example 11 does. We're not going to go through it because I just want to make sure that we have the final 10 minutes for questions or anything that you guys want to talk about. Any questions about DAGs?
So, do you have to annotate them, or can you? I mean, so it's a seed disable.
Yeah.
So
By default, it's true. So you have to opt in.
Can you programmatically specify to turn it on and off at the workload level, right, when you're running it? No.
That's in the works. Yeah, we are, but right now it's part of registration. So as long as it's part of your code, you know. Great question. All right. Any other questions before I go back to the slides? Because I have like a couple more things to talk about. Oh, you do. What's up?
Could you talk a bit more about the you talked about the promotion from like development to staging to production. Is that something that's a first-class thing in Flyte, or is it something that the users of Flyte have to sort of build on top of?
So there is no promotion per se, but we've seen people deploy Flyte where they build like a small amount of tooling to just help you like promote quote unquote versions across project and domains. But it's on you, essentially. Cool. Just to summarize, Flyte helps you orchestrate compute data and infrastructure in an ergonomic way. We love types. Type safety means a lot. We even, you know, as you asked about, like we force people to think about types, at least at the boundaries of tasks all the time. Containers are essential. And this idea to help you go from code in your laptop all the way to production across multiple teams in a large org, it's always in our minds. There's a lot of integrations across, you know, the data science and ML stack. If you're curious about LLMs, there's a Flyte talk happening on Friday where the demo is essentially talking about or using Llama to use training or fine-tuning a Llama model using Flyte. If you want to get involved, we love our docs, but they can always be improved. You can go to docs.flyte.org and start there. Make sure to join our Slack. And all the Flyte code is open source. If you go to github.com/flyte.org/Flyte, everything's there. It's very actively developed, used by a lot of giants in the industry. Quick plug for Union and Union Cloud. We want to help democratize the use of Flyte, and you know, make sure that people can leverage Flyte to solve problems in the world without having to worry too much about the infrastructure. We are hiring. Please come to the happy hour that we're sponsoring tomorrow. Yeah, tomorrow, 7 p.m. at the Locust Cider Redmond. And that's my final slide. Does anyone have any questions? In that case, thank you so much, and I'll be